In this video, I'm going to talk about bosons, or exchange particles. This is part of topic 7.3, particle physics, for the IB syllabus. That means it's relevant to both SL and HL students. Please take a moment to read the success criteria for this video. So in 1930, Yukawa came up with this idea of how to explain how forces can work between different particles when they weren't in contact. And he came up with this idea of bosons, or sometimes called gauge bosons, or we can think about them as an exchange particle. So it's something that two particles have to exchange in order for us to have a force. So I've got a diagram here. I've got two people sitting in kayaks. So they're in the water, and the reason why they're in kayaks is they're very easy to move around. Now let's assume that this one right here has a ball, a big heavy ball, and they throw it in this direction to the other person. So what's going to happen to the person who just threw the ball? Well, they're going to move outwards. Now, when the person on the left here catches this ball, what's going to happen to them since it's big and heavy? Well, they're going to move outwards as well. So in this case, using an exchange particle of a big heavy ball, I have these two people that are going to move away from each other. So we could use this as an example of repulsion. So what if I change what it is I'm exchanging between my two kayaks? For example, say the person on the right now has a boomerang and they throw it in this direction. Yes, it's supposed to be a boomerang. Now, when they throw the boomerang, that means they're going to actually move in this direction, right? We're still using Newton's third law to do this. But my boomerang, as we all know, is going to go around and circle. And let's say it gets over here and circles back before the person on the left can catch it. What will happen here? They will move inwards as well. So what we're trying to show by these kind of examples is if I change the characteristics of the exchange particles, I'm also then going to change the characteristics of what happens to both the person who gives the exchange and the one who receives it. So my example of the big heavy ball would be like repulsion, and my boomerang here would be like attraction. And so depending on what kind of results I'm getting, I'm going to have to come up with different kinds of exchange particles for each example. So that brings us to what kind of exchange particles are we really going to need to know? Now, this table was clipped from our data booklet, and to be honest, most of topic 7.3, if you can understand how to use the data that's in the data booklet, you are well under your way to being able to do this section. Here we are here, particles mediating. That means the particle that's actually causing our force, or if we want to talk about the mechanism behind the force, we call it the interaction. So if I want to know about the fundamental force, we have four of them here: gravitational, weak, electromagnetic, and strong. Let's talk about the gravitational one first. If I'm going to get a gravitational force, then the exchange particle we're talking about is the graviton. Weak force, we'll talk a little bit later in another video about what it works on. Electromagnetic, I'll point out here that this includes both charges, magnets, and their interactions. So if you've ever used the phrase electrostatic, that is a subsection of this electromagnetic. That is just due to charges. But as Faraday and Maxwell pointed out later, they're all connected. And finally, we have the strong force here. And again, we'll talk more specifically on this in another video. So if I want the gravitational force, my exchange particle will be this graviton. If I want to talk about why two positive charges repel, I'm going to be talking about exchanging a photon. Yes, one of those electromagnetic radiations. If I want to talk about any of the other ones, you can see we will discuss these in further detail. Now, I said it's all about the characteristics of the particle we're exchanging. Well, one of the things that we need to realize is that they're not all created the same. Not just because they cause different kinds of forces or interaction, but they also have different ranges over which they work. Now, both the graviton and the photon have no mass, and their range is actually going to be infinite. Our weak interactions and our strong interactions are going to be over a much shorter distance. One last thing I want to point out is we are just scratching the surface about talking about particle physics, and we can get into a lot more detail. Right now, what I want you to think about is that we are going to talk about having different exchange particles for our 4 fundamental forces. We're going to talk about how they have each their own kind of characteristics to cause those different kinds of forces. We know that there's more detail in other places, and we are just going to deal with using the idea of gluons for our strong force, and we are not going to have to go into more and more detail about the color of the force of those gluons. So take one more moment and read the success criteria. I hope you can now satisfy this criteria after watching the video.